Innate immunity in tuberculosis. In case of Mycobacterium tuberculosis (MTB) infection, alveolar macrophages play an important role. These cells are the first cells that take up the bacterium by a process called phagocytosis. Alveolar macrophages (AMs) are able to recognize different MTB antigens, the so-called pathogen-associated molecular patterns (PAMPs). This is made possible through the ability of the AMs to express several pattern recognition receptors (PRRs), such as toll-like receptor (TLR4), TLR2, Dectin-1, DC sign, and NOD21. TLR2 is a crucial receptor involved in the immune response against MTB. It forms heterodimers with TLR1, TLR6 to detect components on the MTB cell wall, such as lipoarabinomannan and lipoproteins. After activation of TLR2, several pro-inflammatory cytokines like TNF-α, IL-12, IL-1 cease are released to control the MTB infection. However, not every PRR-PA interaction is in favor of the host. For instance, manosylated lipoarabinomannan, MANLAM, on the MTB cell wall interacts with DC sign, a C-type lectin receptor, and induce IL-10 production, which is an anti-inflammatory cytokine that leads to inhibition of macrophages and Th1 responses, crucial in fighting off MTB infection. The interaction between MANLAM and DC sign has also a negative effect on the maturation of the phagosome. It modulates a more tolerogenic response, leading to less production of reactive nitrogen and oxygen intermediates, which are toxic for the bacterium. The MTB is also able to prevent the fusion of lysosomes containing acid hydrolases and enzymes able to destruct the bacterium with the phagosome, resulting in survival of the bacterium within the macrophages. Other immune evasion mechanisms of the bacterium are listed in Table 1. Granuloma formation. Macrophages are also involved in granuloma formation. Granulomas are a characterizing feature in tuberculosis disease. They are formed through recruitment of macrophages around MTB-infected macrophages 6. The macrophages are abundant in the inner layers of the granulomatous structure, while other cells, like T and B lymphocytes and dendritic cells, are located around them. The formation of this structure is meant to deal with the infection, preventing it from spreading. However, it also facilitates immune evasion for MTB by staying under the radar for the adaptive immunity 6. Moreover, it could also be an obstacle to drugs to penetrate the layers of degranuloma, making treatment harder. In addition, the center of the granuloma becomes more necrotic over time, creating a structure called a caisson. It consists of cell debris, fatty acids, and cholesterol, resulting in a nutrient valhalla for the MTB8. The central core of the granuloma becomes also hypoxic over time due to limited oxygen supplementation, leading to the development of a dormant state of MTB, which makes them more resistant to the host immunity and to antibiotics, which affect replicating bacteria. Dendritic cells. The other crucial cells involved in fighting off tuberculosis are dendritic cells. These are antigen-presenting cells, APCs, able to activate the adaptive immune system. After recognition by PRRs and phagocytosing the pathogen, the DC will then migrate to secondary lymphoid tissue, where activation of T and B cells take place. To be able to do this, the DCs upregulate the chemokine receptor CCR7, which is important by guiding the cells to the lymphoid tissue 9. In the lymphoid tissue, the MHC2 with the antigen on the dendritic cell engage with the TCR on the T cell. Then a co-stimulatory signal between B7 on the DC and CD28 on T cell follows, resulting in activation of the T cell. Subsequently, polarization and differentiation into the different Th subsets is initiated. Adaptive immune system. After a signaling pathway, CD4 plus T cells are activated, and specifically Th1 response is initiated. These Th1 cells produce different cytokines like IFN, IL-12, and TNF-α, leading to more recruitment of macrophages and improves their ability to kill the MTB1. CD8 plus T cells are also activated. These cells differentiate into cytotoxic T cells after recognizing an antigen. They will then degranulate perforin and granulysin on infected cells, which will cause lysis of those cells.